Well, greetings, business mathematics students. This is Mr. Doucette. This is Business 20, and this is our instructional video on Chapter 5, using equations to solve business problems. And predominantly what we're going to be doing in this chapter is learning how to take a word problem and basically lay it out as an equation that you can now solve to get the solutions that you need. This will be the only basic algebra that we will cover in this class other than doing this. Pretty much all of your problems are basic math problems. There is a little bit of algebraic formulas that you can use in chapter 10 and 11 and 12, but for the most part, this is the only algebra that we touch on. But you'll see how valuable algebra can be in solving these kinds of problems when it deals with, trying to figure out how many of this did you sell compared to how many of that did you sell. And you can really find out a lot by just using basic algebraic formulas or processes. So we're going to be looking at that, but we're going to first talk a little bit about transposing, and this is where you're going to be isolating a variable. Now, a variable is any number that is represented by a letter. So oftentimes it's X or Y, but it can be anything. You might be talking about lamps, so you want to use L. You might be talking about sales, so you might want to use S. You might be talking about accounts, so you might want to use A. Whatever you want to use to represent an unknown number, you can use that letter. And the idea of transposing is isolating what is the value of that variable. And then you can go back, take that value once you figure it out, plug it into the problem, work out the problem. If it works, then you know that you have the correct value for that variable. So that's what we'll be kind of talking about. We'll go over some basic transposing at the beginning of this Zoom session, and then we'll get into some of the more complex word problems, and you'll see how you can take this information and really utilize it to solve business problems. So let me go ahead and share my screen. I'm going to stop sharing here, and I'm going to share on this one. So there we are. You should be seeing my face, and you should be seeing our worksheet. And when you're going to be transposing, and that is isolating the variable, you basically need to move, all whole numbers on one side of an equation so that you isolate just the variable. And at the end of your transposing, you will have the value of that variable. And in order to do that, you need to basically perform the opposite operation as to what's being called for in the problem. So if there's an addition in a problem, you're going to do subtraction to move factors from one side to the other. If it's a subtraction that's in the problem, you're going to use addition to transpose or to move information from one side to the other. If it's multiplication, then you're going to use division in order to transpose and to move things from one side to the other. And if it's division, you're going to use multiplication. So we'll be explaining all that in the beginning of this, and you'll be watching me work that out right at the beginning of this Zoom session. Also, very important, you also need to satisfy or to simplify any parenthesis. So you see here, there's a problem that's being described, and something's not quite right about it. I'm not sure, but as you see here, the goal is to take whatever's in front of the parenthesis and then to simplify it, and that is to multiply each part of that parenthesis by the number that it's being multiplied by, and then work out your problem. We'll be showing you how to do that. In my opinion, there's something wrong with this problem because here we have 3 times 5c, but here we have 23 times 5c. So we're missing something here. And then, anyway, I'll explain later when we get into that in this Zoom session. So I'm going to go up. And then, of course, the big thing you can do at the very end is you can prove that you've found the right value for that variable by plugging it back into the problem, working out the problem, and you should find the solution is true. So that's what we'll be looking at. I'm going to start by explaining a couple of other things. So let me go ahead and delete this form, and we're going to go ahead and load another. So let's load page 2 into our whiteboard so that I can actually write on it, which would be valuable to do. Page 2. All right. So here we are looking at page 2. And we'll give a couple of examples here just to show you what we mean by transposing. So here we have an equation, x plus 4 equals 15. So we want to, it indicates that plus 4, it's addition, right? So it's an addition problem. And to solve for x, you need to apply the opposite operation, subtraction. So in order to isolate this x, we need to move the 4 from one side of the equal sign to the other. So we would just minus it. Since it's an addition problem, we'd minus it from both sides. That means x equals 11. We can go back and we can check. We can put in 11 where x is. 11 plus 4 equals 15. So we know we had it right. Now, you didn't need to do this in order to solve that problem because you could have just took 15 minus 4 and came up with 11. But when we get into more complex problems, this is going to become very valuable. So again, here's the proof. We put 11 in and we got 15. So we're going to solve then some of these other equations and find out what the variable is for each one. And I'm going to utilize this whiteboard to do that for you as we're working it out. So as we look at the first problem here, we have D minus 32 equals 40. Well, again, if we're going to do the opposite, we need to add 32 to each side. So I'm going to do that, plus 32. And if I bring D down, then D equals 72. 40 plus 32 is 72. So I isolated the D. If I go back and I put 72 where the D is and minus 32, it would equal 40. Same over here. It's addition, so we're going to minus 35 from each side. And that means S equals 125 minus 35, which is 90. Here we have addition, again, subtraction. So we're going to add 58 to each side. And by the way, when you add it, these cross out. And the M becomes, in this case, it comes out to 80. Is it 80? 70. 70. So M equals 70. Again, I can plug in 70 where the M is, minus 58 to be 12. All right, now we get to the first multiplication problem. And by the way, multiplication can be represented in algebra in many different ways, or in mathematics, you can do 21k. As we're seeing here, that means 21 times k. You can do 21 times k. That would be valid, or you can do 21 times k. All of them equal the same function. And what did we say? If it was multiplication, we need to do the opposite, which is division. So in order to isolate, oops, my bad, what did I do? My paper, uh-oh. Okay, we're back, I found it. So again, 21k, it's multiplication, so we're basically just going to divide both sides by 21. And again, these two cross out, so k equals whatever 63 minus 21 is, or over 21, that comes out to 3, whole number. Here we have division, so what we do here is we multiply both sides by 3. So 3 over 1 multiplied by z3, so the 2 cross out. So z over 1 is the same thing as z. And then we do the same thing here. We multiply by 3. So 3 times 45 comes out to 135. So z equals 135. And now we've isolated again. Here's 50y. We're going to divide both sides by 50 since it is the opposite function. So y equals 375. I think it's 7.5. 7.5 is the answer. And then down here again is some multiplication or division. So we're going to go ahead and just do the opposite. In this case, we're going to multiply it by 5. Oop, I keep hitting the button. That's what's happening. 5 over 1 times L over 5. So the 2 cross out. That's L over 1, or the same thing as L. And then we do the same thing here. We multiply it by 5. It comes out to 40. So L equals 40. Now here we have one that's a little more complex, so that we need to first move the 5 over. So now we have 6g equals 24. And then we're going to divide both sides by 6 since it's multiplication. So g equals 4, not 6. G. All right, and then this last one, same thing. We're going to add 3 to both sides. So that means that C divided by 4 equals 10, or sorry, equals 13. And then we have then we take 4, multiply both sides by 4, and cross that out. And we're going to multiply this by 4. And then that's your answer, 13 times 4. I don't have 52 is what it is. 52. All right, so that's pretty much what we're talking about. In a few moments, I'm going to show you in a word problem, though, that you're going to actually write out these equations based off the data that's found in the word problem. So, and by the way, all of these problems that I'm doing, they do come from the textbook. They're typically what's used in the textbook to give instruction. Um, so some of them may be from the quizzes or the exams in the textbook. Some of them may be very similar to the quizzes or exams that or questions on the quizzes and exams that you'll take in the course. So keep that in mind. But for the most part, it's really just trying to get the principles of how to do this before you. And then we can obviously, you can apply it to all problems that you might come in contact with. So now we're getting to a few more complex type problems. So here again, we have this 25a equals 11, or minus 11 equals 64. So we're going to add 11 to both sides in order to isolate the variable. So let's do 25a equals 75. And then we're going to divide both sides by 25. They cross out, which means a equals 3, because 25 goes into 75 3 times. Let's see. I'm trying to make sure. Okay, so then we get to this problem here. We're going to minus 33 from both sides in order to isolate the variable, which is R5. So now R5 equals 51. And then we're going to multiply both sides by 5. So if I keep going here, that means R equals 51 times 5 is 255. All right, now we get our first one with parenthesis that we were talking about earlier. And so the first thing you need to do in this is you need to get rid of the parenthesis, and the way you do that is you multiply this factor 5 by 2s, and then you multiply 5 by 1, and you write them separately. So 5 times 2 is 10s plus 5 times 1 is 5 equals 35. All right, so that's now I wrote the equation that way. Now I need to move the 5 over. So now that means 10s equals 30. And I divide both sides by 10. That means s equals 3. Okay, here we have a little bit more of a complex problem because we have more than one item after the equal sign. So the first thing you're going to want to do is put all of the variables together. So we're going to add 2c to both sides. And that gives us 3c plus 5 equals 26. Now we're back to the problems that we had before. We're going to move the 5 over. That means 3c, equals 21. And of course, we divide both sides by 3. That means c equals 7. Here we have, again, another one of these problems. So 12 times 2 would be, to rewrite that would be 24d minus 12 times 4, 48, equals 72. All right, so now we need to move the 48 over to the other side. So that comes out to 120. So 24d equals 120. We're going to divide both sides by 24. That means D equals 5. All right, now we get into a much more complex problem here. And again, the first thing we want to do is got to get rid of the parenthesis, right? So to rewrite this, this might take us more space. Plus 5 minus 5v equals 4v. You're multiplying that plus 4 times 5 is 20. Now I got rid of the parenthesis. Now the first thing I want to do is I'm going to go ahead and do the math over here. So 14v minus 5v gives me 9v plus 5 equals 4v plus 20. And then I'm going to move the 4v over. So minus 4v on both sides. That now gives me the new problem of 5v plus 5 equals 20. And now I'm going to move the 5 over to both sides. So minus 5 minus 5. That means it's going to be 5v equals 15. Divide both sides by 3. And that means v equals 5. All right, and then the last one here, Q10, 20. So I'm going to just rewrite it. Q plus 20 equals 3 times 9. So 3 times 9 is 27 minus 3 times 2 is 6, 6Q. All right, now I want to move the 6Q over. So I'm going to add 6Q to both sides. That crosses out. And that's going to be plus 6Q here. So now I'm going to write the problem as 7Q plus 20 equals 27. All right, I'm a minus 20. I'm going to move it over here. Sorry, folks. So 7Q, I'm going to move the 20 to the other side. So I'm going to do equals 7. Right? So because if I took the 20 minus 20, they cross out, minus 20. That leaves me 7. So 7Q, and if I divide both sides by 7, that means Q equals 1. All right, so I worked all of those out for you, and you will have some of these problems like this on your exams, on your quizzes, but more importantly is the word problems, because now we start dealing with how these apply to business mathematics. So we're going to pick up right into this with our next problem, which is Don and Chuck selling security systems. And then we have another one about checking accounts. So Don and Chuck are salespeople for Security One alarms. Last week, Don sold 10 fewer alarms than Chuck did. Together, they sold 44. So how much did each one of them sell? All right, so we know they sold 44 and Don sold 12 fewer than Chuck did. And we probably could just take 44 minus 12 and say, well, that's what Chuck did, or that's what Don did. Actually, it wouldn't work that way. So we need to figure this out algebraically. And it's pretty simple. What you need to do whenever you're seeing a problem like this very first is which variable, or which person in this case, doesn't have anything related to them at all. In other words, it's just a flat amount. It's not like, for instance, Don sold 12 fewer. So that means Don has 12 fewer attached to his name, where Chuck doesn't have any. So in that case, since Chuck is the one that has none, we're just going to say then Chuck represents X. We're not really sure how much Chuck did. So X equals how many Chuck sold. And then X minus 12 equals how many Don sold. Does that make sense? Because Don sold 12 fewer than Chuck. So X is what Chuck sold minus 12. And altogether, they equal 44. So I can write the problem this way. X plus X minus 12 equals 44. All right, I can rewrite it. 2X minus 12 equals 44. I can move the 12 over to each side. I'm going to transpose it. So now I have 2X equals 56. Is that correct? Yep, 56. Divide both sides by 2. That means x equals 28. So what does that tell me? That Chuck sold 28 sales alarm systems, and Don sold 28 minus 12 because he sold 12 fewer than Chuck did. So he sold 16. So if you add 16 and 28, you get 44. That's how many they sold together. So we solved the problem. So again, I think the key here is finding the person or the reference point that has nothing attached to it. And that's where you'll start with, okay, this is the one we don't know. If we can find that one, then we can solve all the rest. In this case, Chuck had nothing, just that he had sold X amount of alarm systems and Don sold 12 fewer than he did. So we put Chuck as X, Don as X minus 12, and we solved the problem. All right, here we have the next problem. 1/3 of the checking accounts at the community bank earn interest. If there's 2,500 accounts of this type, then how many total checking accounts does the bank have? All right, so we said that 1/3. Oh, goodness, here we go again. I got to figure out how to get back over here. There we go. All right. I don't know, for some reason I keep pressing the button. So. All right, so 1/3 of the checking accounts, so we'll just say 1/3 of checking accounts equal the 2,500 accounts, right? We know that that's what how many accounts are 1/3 of the 2,500 accounts is representative of the 1/3 of all their checking accounts. So we just want to, I pretty much wrote it out. 1/3 of checking accounts, the C represents the checking accounts, equals 2,500. So how many total do they have? All right, all we need to do is do what we've been learning thus far. So we're going to take the 1/3 C and we're going to divide it, multiply it by 3. Keep pressing the button and it's okay. So multiply both sides by 3. All right, these two cross out, which means that C equals 7,500. That's your answer. That one was pretty simple. So you represented 1/3 of checking accounts by this equation, and if they earn interest, if 2,500 accounts are of this type, so 2,500 of the C, so that means that altogether they have 7,500 accounts. All right, we'll work out a few more here. Let's go to our desktop. I think our next page is there. Worksheet page 4. Go ahead and put that on here, and I'm going to delete what we've done so far. All right, this as well. I can select it all. Nope. I know there's an eraser feature. I just gotta find it. There it was. It's here, here. All right. So I erased all that. I gotta find the paper I just placed though. All right. Okay, here we are on page 4. I had to reload it. But we're going to look at the next problem. So it says a local Best Buy store sold 144 TVs last week. If 5 times as many LCD models were sold as plasma models, how many of each were sold? Now, again, we see that the LCD models have something tied to it, 5 times as many LCD models. So we know LCD has 5 times more than plasma. So plasma is kind of our base or our starting point. So we're going to say that X equals plasma TVs, right? We'll write that in there. X equals plasma. And X, or 5X, should I say, equals LCD, since there was 5 times as many LCD as there were plasma TVs. I've still got to get used to this pad I'm working with. So if I was to write that problem out, then on we would write it out 5x plus 5x equals 144. All right, so that's 6x equals 144. That's how we solved that so far. And then we just divide both sides by 6 to find out what x was or how many plasmas there were. So if we divide 144 by 6, it comes out to 24. So that means we sold 24 plasmas, and then we sold 5 times as many LCD TVs. So that's 120. So if you add those together, you get 144. So there, we solved that problem. All right, dollar discount department store sells 3 times as much in soft goods, such as clothing liners, linens. It sells in hard goods, such as furniture and appliances. If a store sales on Saturday were 180,000, how much of each category was sold? All right. So 3 times as many soft goods as hard goods. Well, since again, a variable or a number is tied to soft goods, we're going to have to not use that as our base, but hard goods is the base. That's what it's starting with. So we're going to say hard goods equals X. All right. So we're just going to write, get over here. My hand that's moving it. So X equals hard goods. I'll just put HG. And then they sold 3 times as many. 3X equals soft goods. And again, this is very similar. They all together equal 180,000. So again, we do the same thing. 3x plus 3x equals 180,000. Pretty simple. That would be 4x equals 180,000. And we divide both sides by 4. That means x equals 45,000. There's your answer. All right, this next one gets a little more complex, but it's a lot of fun. Last week, Comfy Cozy Furniture sold 520 items. So we know right off the bat that that's going to be the total, right? So 520 items. And it says it sold twice as many sofas as chairs and 4 times as many chairs as tables. So which variable or which item here has nothing tied to it? Tables, right? So we'll say that X equals tables. And it says there was twice as many sofas as chairs. And then there was 4 times as many chairs as tables. So we'll say 4x then equals chairs, right? Because they said 4 times as many as tables. And then sofas was twice as many sofas as chairs. So that if 4x represents chairs, and so now this equals sofas. Sofas is 2 times as many sofas as chairs, and chairs 4 times as many as tables. Tables are x. All right, so if I wrote this up, it would be x plus 4x plus 2 times 4x. All that equals 520. All right, so we're going to do our math. First thing we need to do is we need to get rid of the parenthesis. So this would be then rewritten x plus 4x plus 8x equals 520. I'm going to write it down here now. All right, so we're going to be merging some of these x's together. We can merge them all together right now if we want. And that's going to give us 13x. So 4x plus 4x is 5. X plus 8x is 13x equals 520. And then we're going to divide both sides by 13. That means x, which would again is represented by tables, equals 40. All right, so if we have 40 tables and we have 4 times as many chairs, so 4 times 40 is 160. We have 160 chairs. And then if there's 2 times as many sofas as chairs, so 2 times 160 comes out to 320. You add all that up and it comes out to 520. So we figured it out. All right. Hopefully that was helpful. Let's go ahead and look at one more. I believe there's one more to look at. Let me see. Desktop. Is that 5? Maybe there's 2 more. Yeah, I think there's 2 more to look at. I think you get the idea now. Yeah, there's a couple more here, so let me delete this one. We'll just pick up right here. 1/5 of employees of Delta work in the Southwest region. My last page. And so if the company employs 252 workers in that region, what is the total number of employees? This is very much like the checking account one we did earlier, the bank account one. So if we say 1/5 of employees equals 252, we already got our equation written out. We just multiply both sides by 5. Those cross out. So E equals 252 times 5. That's 1,200, 1,260 of them. All right. Moving on to the next problem then here. Let's REI Equipment Incorporate sells a 35-liter backpack for $110 and 18. Oh, now we're getting into money. An 18-liter backpack for $70. If the store sold 40 packs yesterday for a total of $3,400, how many of each type of backpack were sold, and what was the dollar sales of each type of backpack? All right, so let's set down some of these factors to start with. First off is we have 35 of them were $110, right? And then we had 18 liter backpack for $70. So 35 liters. So there was, so not the liters, not the numbers. So they were $70. We'll write that down first. All right. And then we know that there were 40 sold yesterday altogether for a total of $3,400. So we're going to write all that down. All right. So how do I figure out a problem like this? Well, in this case, the best thing to do is to take your first one, which is your 35-liter backpack, and they were $110. So we're going to write $110, and we're going to multiply that. We're going to call that 110 times X, right? So X represents the 35-liter backpacks. And then we're going to say, okay, times 70 of anything that's not X. So X minus, should I say, sorry, $40 minus X. Because they were, if X represents the 35 liter and 40 represents the total, then the 40 minus X minus the 35 liter leads me to the 18 liter, right? So 40 plus X equals the 18. So let me go back and say that X equals the 35 liter, and then 40 minus X, because we know if those are the 35 liter, whatever is left of the 40 would be the 18 liter. So we'll call that the 18 liter. All right, so we represented that $110 for the X and then $70 for the 40X, which represents the 18 liter. All of that equals $3,400. All right, so if I do the math on this, then we come out with, first off, the math here. So let's do 110X. 70 times 40 comes out to 2,800. And then 70 times 40, and then 70 times X, so minus 70X equals 3,400. And now I'm going to merge my X's together. So now we got 40X, because we took 110 minus 70. that is going to be added. I forgot there was an add here. 2,800 equals 3,400. I'm going to move the 2,800 over. I'm going to write it down here. That means 40x equals 600. If I divide both sides by 40, that means x equals 15. All right, now we're going to go back and add dollar values to them. So we sold 15 of the 35-liter backpacks, and then we sold the remainder of them were the 18 liters. So how much money did we make? So I think you guys can see it if I go over here to the right. So let's say there was 15 times $110, and then everything 15 is minus 40 is 25 at $70. Right? That was the 18 liter. Oop, bad. Sorry, and I lost that. Let's see if I can find it. Oh, it's gone. All right, no worries. Let's redo it again. So 110 times 70. All right, if I do the dollar value on each of those, it comes out to this comes out to $1,650. And then this comes out 25 times 70 comes out to 1,750. If I add all of them up, they come out to 3,400. All right, so I solved that problem. I think the key here is you start with the higher priced item as the X, and then you take the lower priced item as being the whatever the total is minus X. So if you do it the other way, it won't work out. In other words, if you started with 40, it wouldn't work out because then you'd be dealing in negative numbers, and we don't want to deal in negative numbers in this class. So, all right, we're going to do this last problem then. Chicken Delight sells whole chicken dinners for $12 and half chicken dinners for $8. Yesterday, it sold 400 dinners and took in $4,200. Do I have this one worked out? I like to have them worked out so that way I'm not making too many mistakes when I do it. So here we go. All right. So whole chicken, since again $12 is the higher priced item, we're going to call that X. So X equals the $12 chickens or whole chickens. And then we're going to say 400, let's see, minus X equals the half chickens. And those are $8. All right, so we're going to draw this up. We're going to say $12 for whole chickens plus we're going to say $8 for half chickens. So again, whole chickens is X and half chickens is 400 minus X. So again, whatever's not a whole chicken is a half chicken. And together they represented, $4,200. All right, so we're going to solve this first. So 800 times 400 is 3,200. And then minus 8x. And then 12x plus. All right, so now we're going to merge the x's together. So 12x minus 8x equals 4x. 4x plus 3,200 equals 4,200. And then we're going to move the 3,200 over. And that means 4x equals 1,000. Divide both sides by 4, and x equals 250. So they sold 250 whole chickens. Let's do whole. And then that means if there was 400, so 400 minus 250 means they sold 150 half chickens. All right, so if I put a dollar value to that, 150 times 8 and 250 times 12, that means that this was $1,200 for these and 3,000 for these, means a total of 4,200. That's my answer. So there was 1,200 whole chickens, half chickens sold, and 250 whole chickens sold. So again, we used algebraic formulas to solve these classic word problems. So, all right, well, that's pretty much it. We're done with this Zoom session. Hopefully it was helpful for you to work it out, for me to work it out for you. Make sure you apply this to the problems that you'll be working out in Chapter 5, as well as on the quiz and exam. If you have any questions at all, you're always welcome to reach out to me during my office hours, whatever semester it might be. You might be watching this in a future semester as it's a new video. I'll be posting this one as a teaching video for this chapter. But look on the homepage of our class. There should be an office hours link that lets you know when we can meet. You can also text me or reach out to me at any time, and we can set up an appointment that maybe works a little better for you. So thanks for your time today, and hopefully this was helpful. Have a great rest of the week and a great semester.